No, we should talk about that. Sorry.
That's all.
All right, guys, time to go. We have a lot of stuff to do today, and I really, really want to get to 5-2. So,
Some of us are going to the show party.
I received this person.
Cindy's absent.
Always came to the store when the first week was
All right. Yesterday we solved a big trigonometric equation. Here we go. We are doing the same thing today. Now, as with all things mathematics, there are many, many, many different ways to approach every problem we do. My suggestion to you when you look at this is to know we don't divide by sign, right? We don't divide by sign. Never. We don't, unless we are absolutely sure it's not zero, we can't divide by it. So we're going to subtract the sign. Chris has amended his idea, and so I'm going to subtract sign so that I can factor it out and accomplish the same thing, right? Now I have two expressions, sine and tangent squared, minus 1. All right, does everybody follow what we did there? Now, there are other strategies you can do, but I want to remind you that if you choose to change this into sine squared over cosine squared, which is an option, you're then going to have sine cubed, and you're going to have to deal with that. So it's probably just easier to do what Chris suggested, subtract the sine over and factor it out. Now, where is the sign 0? Keep in mind, there is no triangle that has the opposite side 0. Right? It's not possible. So where do we look? If we can't look on the triangle, we have to look on the circle. And somewhere around the circle, the sine value is 0. Where does that happen? Right here, and right here. So the answers to the first part of the problem are x equals 0 and pi. 0. Everybody still with me? All right, so now I'm coming over here. Tan squared equals 1. So tangent, square root both sides, tangent equals plus or minus 1. Remember when you take the square root, you have to do plus or minus? Well, now wait a minute. Where is it that the tangent is either positive or negative?
Everywhere.
Isn't that everywhere? That's everywhere.
Yeah, that is
Because the tangent is positive here, and it's negative here. Tangent's y over x. Opposite over adjacent. So there are 4 answers to this one. Okay, so what are they? Well, the tangent's 1. How big is that angle right there? 45, but I'm in radians, so I'll say pi over 4. So all these are pi over 4. They're always going to match. You're never going to have 2 different angles in the same equation like this. Okay? So now you're just going to have to sit down and wait a minute because I'm in the middle of something cool. Now, what are the answers of the problem going to be? There are 4 of them. So the first one is pi over 4. The next one is 3 pi over 4, which is pi minus pi over 4. The next one is pi plus pi over 4, pi plus pi over 4, which is 5 pi over 4. And then the last one is 2 pi minus pi over 4, which is 7 pi over 4. That is exactly right. So, I think, was it you, Maren, that asked me yesterday, is there a way to know how many answers there's gonna be? Oh, Sydney, I'm sorry. And the answer is no. This one has 6 answers, right? There's just no way of knowing when you start. All right, let's look at the next one. No calculator. You can use your purple sheet if you haven't. You can use the front of your purple sheet.
Really?
All right. Let's look at the next one. I don't know, that seemed a lot easier than yesterday. I think we're smarter. Okay, here we go. C. What do you think of when you look at this problem?
Quadratic.
It's quadratic. Everybody see that? So I'm thinking, all right, I think I'm gonna try to factor it. So what will my factors have to be? 2 sign and 1 sign. And I think 1 and 1 is about all the options I have. Does that work out for me? Outsides and insides add up to 3.
Yeah.
So here we go. 2 sine plus 1 equals 0, and sine plus 1 equals 0. So sine equals negative 1/2, or sine equals negative 1. Now these are not the answers. Remember, the answers are angles. So we gotta find the angles that make this happen. So where is the sign negative? On the bottom. In other words, quadrants 3 and 4. So this is where the sign is negative. Opposite over hypotenuse. That's a 30 angle, right? A 30-degree angle. But I'm in radians, so 30 would be pi over 6. They're both the same. They're going to match every time. Pi over 6 is not an answer, though. An answer would be this, which is pi plus pi over 6, which is 7 pi over 6. Or this purple one, which is 2 pi minus pi over 6, which is 11 pi over 6. Those are the answers to the first part of the problem. All right, now, I want you to think about this one for a second. If you think about a triangle here, wouldn't that mean adjacent and hypotenuse were the same? Can't be, right? That's not possible. So we're not going to draw a triangle. We're going to go back to our circle. And we're going to look around the circle until we find the point where y over r is negative 1 over 1. Where does that happen? At the bottom. So that angle is 3 pi over 2. So this problem has 3 answers. Leah?
And on these ones, we don't need to do the, or do we need to do the plus 2 pi?
No, because I didn't write the directions down, but they're up there at the top. It says we're between 0 and 2 pi. Look up there at the very top.
Yeah, but then on A and, oh, then on A, I think we.
No, I don't think it was A, I think it was one yesterday we did. I think it was number 7 we did that. One more. Somebody yesterday, I can't remember who it was, gave us a perfect lead in to this problem. We have an issue here, and the issue is there are two functions, and we had one earlier where we did a subtraction, but after we subtracted, we could factor, right? This is not working. We're not gonna be able to, I mean, we can subtract, but factoring, there's no factoring to be done because we have sines and cosines. Tell me about cosine squared. There's something special about cosine squared. It's important. This is a biggie. You need to know what cosine squared is.
Wait, this could be completely wrong, but are we talking about like cosine squared plus sine squared?
That's exactly what we're talking about. Sine squared plus cosine squared is 1. That is true. So what does cosine squared equal? 1 minus sine squared? Every squared function can be rewritten as its Pythagorean, in terms of its Pythagorean mate. So sine squared plus cosine squared is 1. So cosine squared can be written in terms of sine squared. Cotan squared can be written in terms of cosecant squared, and so on. So, how does that help me? Well, if I change my cosine squared into 1 minus sine squared, now my problem has one function in it, and doesn't it look a lot like this one? It's not cleaned up, but do you see a similarity there? Liam?
You wrote 2 sine instead of 3 sine.
Oh, yeah, thank you. That is a 3, thank you. Yeah. That would make a difference, so I'm glad you caught that. All right, so what do we got here? We've got 3 sine equals 2 minus 2 sine squared. What do you suggest we do with that? Move it all over and get it set equal to 0 because it's a regular quadratic equation. So 2 sine squared plus 3 sine minus 2 equals 0. Keep an eye on my arithmetic. I'll have to do another careless thing. Is that all right?
How do we, because, so we can just transfer the negative to 2?
I subtracted this over here, added this over here. Regular equation stuff. All right, does that factor by any chance? I need a 2 and a 1. How's that look? Remember when you said to your Algebra 1 teacher, wait a minute, we're gonna have to do this again? Yeah. All right, so sine equals 1/2, or sine equals negative 2. Chris is drawing a graph right now because he's gonna figure out where the sine equals 1/2. So where is the sine positive? In quadrant 1 and 2, so up top. That's where sine is positive. Because sine is y, right? So opposite over hypotenuse, that makes this angle how big? Pi over 6, good, you're thinking radians, very good. Pi over 6, 30 degrees. So we need our angles. So the pink one is easy. The pink one is pi over 6. And then the purple one is what? Pi minus pi over 6, which is 5 pi over 6. Very, very good. Test? Huh? Get your hand away from your mouth and talk loud.
Oh, wait.
Lee. You got it?
Yeah.
Okay. Now, tell me about this guy right here.
How does that work?
Not possible. Not possible. Kids, think about it in fraction form. Wouldn't that mean that the opposite side was 2 and the hypotenuse was 1?
Oh, yeah, you can.
Is that possible? No, so that one's extraneous. And this one only has 2 answers. These 2 right here are the answers to the question. Lucy?
So I'm confused how you know like that now it's extraneous, but on other problems you do the circle, like the points. And those are ones before.
Yes, and it's possible to have 1 over 1. That's possible. But you're never gonna have 2 over 1. That would mean the y coordinate was bigger than the radius. Right? That would be like, here's a circle with a radius of 1, but we're talking about y, actually negative. We're talking about y being down here. That doesn't even make sense.
So for sine and cosine, if it's like larger than the number 1, just like
Yes.
okay.
Now, before we like memorize another piece of stuff like that, I want you to think about this, Sydney. When you graph a sine and a cosine, the regular sine and the regular cosine, how high and low do they go?
Yeah, they never go above 1.
Exactly, unless you put a multiplier on it or
Yeah.
something, right? But the regular sine is never gonna be more than 1 or less than negative.
Okay, cool.
Okay, does not exist. Okay? Now, those were equations. These things, like this problem we just did, that's an equal sign as long as you either have this answer or this answer, right? Otherwise, they wouldn't equal. This is the only way they equal, is if we have these 2 angles. Now we're ready for 5-2. So 5-1 is going to be due on Thursday. Okay, 5-1 is going to be due on Thursday. Now we're moving on to 5-2. This is not a solve. We are not solving this. We are proving, hopefully, that this is always true. All right? And we do that by picking one side or the other, only one side though, and transforming it into the other side. Okay, so for example, I'm gonna pick this side to work on, and I'm gonna mess around with it, do whatever I can do to it, and hopefully, I'll go through a series of steps, and hopefully I will end up with my last step. This side is not changing, this side, every step, this side staying the same, but you see what's gonna happen? If I'm able to change this, eventually I'll have secant cosecant equal to secant cosecant, which we all know is absolutely always true.
So we're changing the, does it matter which side?
No, if it's provable by changing this into this, then the reverse steps obviously would change this into this. Now, having done this for a long time and totally loving it, so like this is something I do for fun, I love these things. I've done a lot of them, and you know, like with everything, the more you practice, you learn little tricky things and whatever. So, here is my first little piece of advice to you. If you have one side of your problem is an add or subtract, And the other side of your problem is a times or divide. It's usually easier to work on the add and subtract side. And here's why. I'm gonna change these into sines and cosines. They're going to be fractions, right? I'm gonna be adding fractions. So then I'll get a common denominator. So I don't know where that's gonna take me, but it's steps, it's things to do. I can see what I need to do. It's a little harder to figure out what to do on this side, because once you change it into sines and cosines, you're kind of stuck. Over here, it's easy. So I'm gonna change this into sine over cosine. By the way, that's my second hint. You can't think of anything else to do. Change it into sines and cosines. Everything changes into sines and cosines. So that'll at least give you some kind of common ground. So is everybody okay with, these are called the quotient identities? Oh, by the way,
Is it our test?
oh, grab those. I ran these off for you. These have the identities on them, so take one and pass them around. So that is a handy little sheet you can keep with you. I know they're all in your notes, but to kind of, you know, you have to look around and everything. So here's a handy little sheet for you. Okay? I've got some other things to turn back to, and I'll do that in a minute when I'm done with this problem. All right. So I'm going to get a common denominator. Now, what is my common denominator going to be? Cosine sine. Okay, that's my common denominator, cosine sine. The first fraction needs a sign. Remember, if you're going to put one on the bottom, you have to put one on the top. The second fraction needs a cosine. So what do I have on top? I know my bottom, my common denominator is cosine sine. What do I have on top? Sine squared plus cosine squared, which is 1, I mean there's a line here, 1 over cosine sine. Now we don't normally do this, but can that be split into 1 over cosine times 1 over sine? Think about that, is that the same thing?
Wait. Yes, but why? Like, why are we doing
Because I want to end up with secant times cosecant. And did I?
Oh, yeah.
I did. And that was my objective. My objective was to show that this side could be transformed into this side or vice versa. Okay? We only work on one side. So once you commit, you work on that side. No change in this side unless you want to work on that side.
When we're doing these, are you always gonna give us one that's equal and it's just our work that you're checking?
Oh, that's a great
'Cause I was
question.
kinda
Just trigger us, we're all
jumping steps a
frustrated.
little bit.
So, so first of all, you have to show enough steps that I can follow what's happening, okay? So there are times when, you know, she might do it in, just like geometry, she might do the proof in 10 steps, but you might do it in 6. And that's okay. As long as I can follow your thought process, you're good to go. Your other question was, are they always gonna verify? Today they are, but part of the fun is discovering the ones that don't verify and figuring that out. But I'm not doing that too much. Okay? All right, so I've got a few papers to hand out. I need you to get started on this one. So I want you, and you can work with your partner, But while I'm handing out papers, I want to see how far you can get. And please, please, work on this side. Work on this side. It's going to be easier to do this than it is to try to turn that in. So work over here. Figure out what your plan is.
It'll be something like or plus. You want to do the CH? I'm gonna try to do this one.
Work over here.
Oh, it's just you're doing different. Oh shoot! Oh shoot!
Oh, no.
Oh, it is. Yeah. Oh, wait, should we like foil? Yeah, foil the denominator. Yeah, you got the top right. I got the top right, and just foil the denominator, which is first 6 squared outside, inside left, minus 1. Okay, that makes sense. Okay. That makes sense for now. Okay. And then it's gotta be like it's gotta be a row in here.
What? You say this is
gotta be a row.
Isn't that just sign?
That's the same thing as cosine. 1 over cosine minus
Okay, you know what? I'm just sorry about that.
There's gotta be a rule here somewhere. Whatever you know what to do, just look forward.
Okay, let's do that.
Oh, we're gonna test. Oh, that's the bigger side.
Alright, we're gonna see what happens here. And that was ironic because it was like nice. And then you guys.
There's like some like rule where it's like, oh, the wood continue everything. Okay. We have to come in now.
What if we took like this slope? No, you
No. Is this his birthday?
we got two we got a common denominator. That's right.
I will say 1
I don't know where to go after that.
So there's the white one.
Okay.
Getting the common denominator.
This last problem we're gonna do today, and I wanna get going on it so we can make sure we get it going. So let's hear some ideas. What were some ideas you had? Do I have any extra reference sheets, by the way? Did they make it all the way around? There should have been some extras. Anybody have more than one reference sheet?
I think I'm doing it already.
Secant equals.
Okay, you think you did that, right? All right, tell me what you did.
Okay, so I got a common denominator first so I could add them, so I did like the opposite of like, yeah.
All right, so let's start like Maren did. She said, and again, stop. Could you do something different to get started? Yes. I think her idea is a great one. She says, I got 2 fractions to add together. Whenever I add fractions, I get a common denominator. So this is going to be my common denominator. This fraction needs a secant plus 1. And this fraction needs a secant minus 1. Right? You with me? So what do I have? Here's my bottom. What do I have on the top? I have secant plus 1 plus secant minus 1.
2 secant x.
So I have 2 secant. By the way, I like that too, don't you? So I have 2 secant over
Why didn't I think about that?
secant squared minus, oh wait a second. As soon as I wrote secant squared minus 1, my heart starts pounding because there's an identity that says 1 plus tangent squared is secant squared. So So secant squared minus 1 is the same as tangent squared. So now I've got 2 secant over tangent squared. Important point. I know I am saying 2 secant over tangent squared, but notice I'm always including my variable when I write it. Now that's important. Just writing this is meaningless. It must have an angle attached to it. That's going to become important, really important, when we have identities that have x's and y's in them. You're going to have to be able to know what hooks together and what doesn't. Okay, so make sure, even though I'm not saying it, make sure you're including the x or whatever variable you're using. Okay, Mary, now it looks great. Now
Okay, so
what?
that's actually only as far as I got.
Well, but let's look at this for a second. This is where you're heading, right?
Yeah.
So let me just separate this for a second. Could I write this as 2 times secant times 1 over tangent squared? Is that legit? Can I do that? Okay, what's 1 over tangent squared? Cotangent squared. So 2 times secant times cotangent squared. Now, what's secant?
1 over cosine.
1 over cosine. What is cotangent squared? So I could think of it as cotangent times cotangent. And then that cotangent could be cosine over sine.
Hold on.
Okay, now again, I'm going with Peter here. You may not be thinking on that wavelength, but he said, certainly cotangent squared is cotangent times cotangent. Now, the reason Peter didn't want to change both of those is because what do I have in my end goal? I have a cotangent. So if he got rid of both cotangents, that's okay, but he'd have to get one back because I gotta end up with a cotangent. So he said, all right, I got 2 of them. I'm gonna split them apart. I'm gonna leave this one as a cotangent, but write this one as cosine over sine.
Wait.
Now, what happens when I multiply these 2 things together? The cosines cancel. So what I have left, I'm totally out of room here, what I have left is 2 times 1 over sine times cotangent. What's 1 over sine? So 2 cosecant cotangent.
I'll go downstairs.
Wait, is that the cotangent equaling cosine over sine? Where is that on our calculation? Is that on the sheet?
Yep.
No, we're not.
No, I like seeing it when it's close up.
I'm here as a guy.
Is it this?
Nope, Danny, you better memorize that one because it's not on there.
So, it's just this in our quotient.
Tangent is sine over cosine. Cotangent is cosine over sine.
Are those the only quotient?
And we use them all the time, so they ought to be automatic for you. And I talked about this yesterday, they're not even strange, because sine is y, cosine is x, and tangent is y over x. So it makes sense that tangent would be sine over cosine.
What's code?
Did you just ask me if tangent sine over cosine, you better know what cotangent is. Okay. Now, this problem could be done other ways, right? But the moral of the story is, you gotta get it done. So, if you get to a point and you're not sure what else to do, then go back and start over with a different strategy. So an example of a different strategy. In the beginning, it would have been messier. I love this plan. I think this is the way I would start if I found this problem somewhere. But if this wasn't working for me, what do I know about secant? Right in the very beginning of the problem, what do I know about secant? It's 1 over cosine. So if I wanted to try that and see where that led me, that would be another attempt. On test day or quiz day, you get no points for no work. So if you get along a ways and get stuck, don't erase it all. Just draw a line and say, I'm starting over, and start over. Because I can't give you points if you've erased everything. Just like geometry. Some of you are gonna pick this up in a snap. You're gonna fly through these things. And some of you are gonna be like, oh my gosh, and you're gonna be the ones that do it in 30 steps. But you know what? It's still, it's still fun, as long as the 30 steps are okay. All right. Now, I'm gonna tell you, you guys have no idea. Some of you maybe have met Mr. Ford. Mr. Ford is a fantastic